Good afternoon, everyone. Today we're going to do a surface area problem with a right cone. So, having a quick look at it, we're given the diameter of the circle that forms the base, and we're given the vertical height of the cone. What we're not given is the slant height of the cone, which we will need to get the surface area later on. So, first off, let's remind ourselves of our general surface area formula for a right cone like this. We have pi r squared. That comes from the area of the circle, so the area of the base, which is a circle, right, pi r squared, plus the lateral area, that is the area around the cone, is pi r s, s being the slant height, and r being the radius of the circular base. So we have r, because knowing that the diameter measures 12 centimeters, we can quickly get our radius by dividing that by 2. And so we know that our radius measures 6 centimeters. Okay? Now, much like we can do with pyramids, using the vertical height and half of the side lengths to construct a nice right angle triangle, you might be able to see that being a possibility here as well. Right? When we're doing surface area and these kinds of problems, we often look for right angle triangles because the Pythagorean theorem allows us to get whichever length that we're missing. So, with the diagram shown as it is, we can see that this bottom side length is exactly one radius of the circle, which we found to be 6 centimeters. The top side of the right angle triangle is going to be the vertical height, which we were given to be 20 centimeters. And now the slant height is obviously the same on both sides, and so we can call that s as well. And now we can use the Pythagorean theorem. So we have that s squared, since s is the hypotenuse, is equal to 6 squared plus 20 squared, right? And now, if you're familiar with this, you can just run through it. S squared is equal to 36 plus 400, and so s squared is 436. And so, again, the inverse of the square is the square root. And so we take the square root of both sides and find that s is the square root of 436. And so we find that s is roughly, let's say, 20.8 or 9. Let's check that. Square root of 436 is 20.88. Let's round that to one decimal place. And let's say our slant height is 20.9, right? And we can add the units here in our diagram, 20.9 centimeters. Now we have all parts of our formula for the surface area of the cone. And so we can go ahead and write that out. Again, I'll just mention that pi r s, same way that pi r squared is the area of the circle that forms the base. Pi r s is the lateral area, which you might have read or heard of. And so now we can go ahead and plug our values in. And so we have pi times r is 6. So pi times 6 squared plus pi times, again, r is 6. And s we calculated to be 20.9. And so let's run through that. Pi times 6 squared. Let's pop that into a calculator. You can use 3.14, but I'm going to encourage my students to use the pi button. It's pi times 36. That is 113.1 plus pi times 6 times 20.9. So that's 20.9 times 6 times pi. It is 300, and let's round that to 394.0. If we round again to one decimal place, to a tenth of a square centimeter. And now we can finish off our solution by putting those together, and our total surface area is going to be 500, whoopsies, is going to be 507.1, and one surface area, which is two-dimensional. Our units are all expressed in centimeters, and so our units are going to be squared centimeters. And there we have it. So, again, I hope that helps. If you have any questions, comments, suggestions, please do leave a comment down below. Thanks for watching.